Ever wished you could make a complicated electrical circuit behave like a simple one, especially when analyzing its behavior at specific terminals? Mastering the calculation of Thevenin equivalent resistance, often called RTH, is a powerful technique that helps you do exactly that. When computing the Thevenin equivalent resistance, or RTH, for a circuit containing only independent sources, you need to systematically deactivate those sources before calculating the equivalent resistance from the perspective of the load terminals. This approach simplifies complex networks into a basic equivalent circuit. The fundamental principle behind deactivating independent sources for RTH calculation is to determine the equivalent resistance of the network itself, effectively viewing it as a passive circuit. Independent sources, by definition, supply energy regardless of the circuit conditions, and to find the inherent resistance, their energy contributions must be temporarily removed or set to zero. This ensures that the calculated RTH truly represents the circuit's internal opposition to current flow, distinct from any active source behavior. To practically apply this, first identify all independent voltage and current sources within your circuit. For each independent voltage source, replace it with a short circuit, meaning a direct wire connection with zero resistance. Simultaneously, for every independent current source, replace it with an open circuit, which means breaking the connection and creating infinite resistance. Once all independent sources are deactivated in this manner, you can then calculate the total equivalent resistance by looking into the terminals where the original load was connected, using standard series and parallel resistance combination techniques. This methodical approach ensures accurate RTH determination. An important insight here is that dependent sources, unlike independent ones, are never deactivated when calculating RTH. They remain as active as their values depend on other circuit variables. Recognizing this distinction is critical for correctly applying Thevenin's theorem. This method provides a clear path to simplify circuit analysis by reducing a complex network to its simplest equivalent resistance. By diligently following these steps, you gain a deep understanding of a circuit's internal resistance characteristics, independent of its active energy delivery. This mastery allows you to predict circuit behavior more effectively and efficiently, transforming seemingly intricate problems into manageable segments for precise analysis and solution.